Hello everyone and welcome back. Today we are going to learn about paging, segmentation and page segmentation, the topics that was promising to get you. So, without before understanding the topic, let me give you an example. Imagine you are storing your valuables in an open room where anyone can access them. It is very risky, right? So now imagine keeping them in a secure bank vault where each locker is protected and only accessible to its rightful owner. This is exactly why memory protection is important in a computer system. Without protection, the program would access and modify each other's data, leading to system crashes and security risk. In today's video, we will break down four key concepts that help manage and protect memory. Protection schemes, paging, segmentation, and paged segmentation. So let's get started. Firstly, what are protection schemes and why do we need them? So, protection scheme ensures that the process cannot access memory that does not belong to them. It is like that the protection scheme ensures that if something do not belong to you, you cannot access that. So, why do we need? Firstly, a faulty or malicious program can corrupt the system memory. So, to avoid this, we need protection. Then, multiple programs running together may accidentally overwrite each other's data, even if they do not want it or it was not that program's intention. Then we have the unauthorized access, which can lead to security breaches, which hackers touch daily. There are some types of protection schemes like we have the base and limiters. Okay, base and limit registers. The base register holds the starting address of the process. The limit register defines the maximum memory range a process can access. Like a hotel key card, it will only open your assigned room, not others. Then we have access control list. Each memory segment has a list of processes that can and cannot access it. Similar to a guest list at an event, only those on the list can enter, and if your name is not on the list, are not allowed to enter. Then we have memory keys. Each memory block is assigned a security key, and only processes with the correct key can access it. For example, when you use encryption keys, okay, in the encryption keys in the WhatsApp chats, they are used to unlock the digital files on the internet. An example of this will be the operating systems like Windows and Linux use these protection schemes to prevent the unauthorized memory access and keep the system stable. Now, the most important topic, paging, that you all have been waiting for. So, paging is a memory management technique, yeah, that divides memory into fixed size blocks called pages. It is like the fixed size partitioning that we learned. In the paging divides the memory into fixed sized blocks. Each program is broken into pages of the same size. The operating system keeps track of pages in a page table. The physical memory is divided into frames where these pages are stored. Now, let me repeat it again for you. Each program is broken into pages of the same size. The operating system keeps track of pages in the page table, and the physical memory is divided into frames where these pages are stored. Now, think think of a book, the book that you read divided into pages, each page numbered, right? And you can access any page independently anytime you want. But there are some steps also. So how do we do the paging? The firstly, the process is divided into equal size pages, like I mentioned. Then these pages are loaded into available memory frames. After this, the page table uses maps logical pages to physical frames. These were the steps. Then Coming on to the problems, the paging is not perfect, so it has its own problems also, like the internal fragmentation. If a page doesn't allow the entire allocated frame, space is wasted, like the fixed size partitioning we saw. Then we have the slower memory access. It means that it requires page table lookups for memory access. An example is like the modern operating systems like Windows, Linux, and Mac OS use paging also to efficiently manage the RAM and the virtual memory. So, then segmentation. What is segmentation? Segmentation is a segmentation technique, right? No. Segmentation is a memory management technique that divides programs into variable size logical segments. What? Variable size partitioning. Remember that part. So, in this, each program is divided into different segments like code, data, stack, and heap. These are the type of data structures that we have already studied in our programming part. Each segment is placed in a separate memory block, and the segment table keeps track of segment locations. Think of your university. In the university, each student is organized records into different files. One file for grades, one for personal details, and another for course enrollments. So, but what are the steps in segmentation? How do we do segmentation exactly? Firstly, the operating system is divided into logical segments. The OS allocates separate memory space for each segment. The segment table then maps logical segments to physical address like the paging. As I mentioned, nothing is perfect, so there are some problems also. Like the in the paging there was internal fragmentation, but between segmentation there is external fragmentation, which means that there will be some unused memory blocks which will exist between these segments. And then we have the complex memory management. It means that it will require segment tracking. An example is programming language like C and C++, if you are familiar with, they use code, data, and stack segment in memory. Now, we learned about paging, we learned about segmentation. There was some advantages and some disadvantages also. So now combining the both the advantage of paging and the advantage of segmentation, we formed paged segmentation. It combines both for efficient memory management. Each segment is divided into pages of fixed size. The segment table maps the segments while the page table maps pages within each segment. Now, think of a real large book series. Okay, like the Harry Potter one. There were 8 volumes, I think. So, where each volume, volume one, volume two, volume three, is divided into chapters. So, think of the volumes like the segment and the chapters in the volume like the pages. So, how do we do the page segmentation? Firstly, the program is first divided into segments. Okay, then those segment is further divided into pages, broken down into pages. The OS will maintain both a segment table and a page table for the lookups. So, but there are problems with this also. What are the problems? Firstly, we require two levels of data table to increase the lookup time because we are using two things, segmentation and paging. But still, after all this, even doing all this, it is still prone to fragmentation. Even though it is less, but it is prone to fragmentation. An example is like the previous examples, like the modern operating systems. They combine paging and segmentation for better memory efficiency in applications like memory management. So to summarize, we what we learned today. Firstly, we learned about protection schemes which keeps safe memory or memory safe from unauthorized access. Then we learned about paging, which divides the memory into fixed size pages, which is derived from fixed size partitioning that we learned about in the previous lectures. Then the paged segmentation. It combines both the advantages of paging and segmentation for better and efficient memory management. These concepts are the foundation or the fundamentals of modern memory management in operating system like the Windows, Linux, or even the Mac OS. Sorry, everyone. Yeah. So, if you found this video helpful, don't forget to like, share, and subscribe for more tech explanations. See you in the next one. Thank you.